Hello everyone and welcome to this tutorial. Till now we have completed all the data pre-processing steps. From this tutorial we will start the model building. Let us begin. Add a subsection. First we will try multiple linear regression. To take the reference, go to sklearn documentation. Here we have to search for linear models. Scroll down. This one, linear models. And here we have to look for linear regression. This one. So this is the class that we are going to use, linear regression, and we are going to import this class from sklearn.linearModel. From sklearn.linearModel, then import linear regression. Close this. These are the details. Let us save this first. The notebook has been changed outside of session, like to overwrite, yes. This is one more advantage of using Google Colab. Saved successfully. Great. Let us understand this class, linear regression. Ordinary least squares linear regression. So the linear regression fits a linear model with coefficients to minimize the residual sum of squares between observed targets and the predicted ones. In short, it tries to minimize the error. Now scroll down. Let us see the examples. So here also we have to define an instance of this class. So define instance of this class. Regressor underscore multiple linear regression is equal to, so this is the instance of this class. We will use all the parameters as default, and to train the model use fit method and in parentheses specify x train and y train. That's it. Let us understand this again. First we have imported this class linear regression, and we have imported this class from sklearn.linearModel, and after that we have defined an instance of this class linear regression, and after creating the instance we are training the model using this method fit. Now execute. Great. So we have successfully trained our machine learning model. Now we have to do the predictions. Define a variable ypred is equal to regressor underscore mlr dot use the predict method and in parentheses x test. Execute. Great. So we have stored the predicted values in this variable ypred. Now we have to analyze the performance of our machine learning model. And to do that, go to sklearn documentation. Here we have to look for matrices. This one. Then scroll down. Here we have to look for R square. This is for classification matrices. We have to look for regression matrices. This one. R2 underscore score. So we have to analyze the performance of our machine learning model by using this class R square, and best value is 1. It can be negative as well. Let us import this class from sklearn.matrices import R2 score. Execute. Now use this class R2 score. In parentheses we have to specify y test, and after that we have to specify ypred. That's it, and execute. Great. So the value of R2 is -1.11. So this is the performance, and here you can see best possible score is 1 and it can be negative. So we can say that this is not a great performance by our multiple linear regression model. Let us try one more regression machine learning model. Add a subsection. So this time we will try random forest regression. Go to sklearn documentation and then API. Here we have to look for ensemble. Scroll down. Ensemble methods. This one, random forest regressor. Open this. So this is the class that we have to use, random forest regressor, and we have to import this class from sklearn.ensemble. From sklearn.ensemble, then import random forest regressor. And after that we have to create an instance of this class. So I'll just copy this instance, regressor underscore MLR. So here we will call regressor underscore RF, that is for random forest. And this is the instance of this class, random forest regressor. So this random forest is a meta estimator that fits a number of classifying decision trees on various subsamples and uses averaging to improve the predictive accuracy and to control the overfitting. And these are the all parameters that we can specify, but here we will use all the parameters as default. And after that we have to train the model. Copy this instance, use the method fit xtrain, ytrain, and execute. It will take a little bit time. Great. So here we have successfully trained our machine learning model. Now redefine ypred so we can analyze the performance. Instead of regressor underscore MLR, specify random forest and execute again. Great. Now calculate the R2 score. I'll just copy this line as well. So paste, copy this one as well, and execute. So this is the R2 score 0.83, which is much better than the multiple linear regression. In multiple linear regression it was minus 1.11. So here we can say that random forest regression is working better than the multiple linear regression. So this is our second model that we are trying. Let us try one more model. XGBoost regression. Add a few lines. From XGBoost, import XGB RF regressor. After that create an instance, regressor underscore XGB, and this is the instance of this class. We will use all the values as default. Then use fit method to train the model, xtrain, ytrain, execute. Xtrain, TRAIN. So here we have successfully trained our model. Now redefine ypred. Instead of regressor underscore RF, use regressor underscore XGB. Let us check the performance with the help of R2 score. So the R2 score for XGBoost regressor is 0.69. This is our third model that we are trying. So on the basis of R2 score, we can say that XGBoost regression is working better than the multiple linear regression, but it is not better performing than the random forest regressor. So here we will finalize our model as random forest regressor. This one. Now add one more section. Part 3. Hyperparameter tuning, or we can say that hyperparameter optimization. Let us revise what we have done till now. From this tutorial, we have started the actual model building process, and we have tried these three different regression models: multiple linear regression, random forest regression, and XGBoost. And on the basis of evaluation, we have selected this one, random forest regression. That means we have finalized our regression model as random forest regression. After finalizing the model, we have to do parameter tuning. So we will do parameter tuning in next tutorial. Till then, happy learning.